Excellent. Thank you very much, everybody, for joining. March 16th, Tinkerbell call. This is the EMEA time zone call. We, as always, kind of track everything in the Tinkerbell contributors meeting Google Doc. So please feel free to add yourself as an attendee if you would like. These calls are always recorded and then placed on the Tinkerbell YouTube channel, so that everybody can find them. For new faces, welcome. We have a code of conduct for you to read through, but effectively be nice, treat everybody as you'd like to be treated yourself, and welcome. I notice we do have one or two new faces. If you would like to introduce yourself, please feel free to unmute yourself and do that now. If not, we will kick off today's list of topics.
Yeah, I'll just say hello to folks. I'm Scott Garman. I'm on the Tinkerbell team. We're starting to work closely with James on stuff and get working with the stack. I work for Equinix.
Fantastic.
And I'm Dave. I go by DCH pretty much everywhere on the internet. I said hello last week, but then yeah, family stuff conspired against me, and I'm mainly interested in FreeBSD related stuff because that is what I do. I tried end of last year to build Tink on FreeBSD successfully, but didn't get as far as actually running it. And what I'd like to do is see how far I can get with that, running it in FreeBSD ports. I'm kind of aware that once I get past Tink and get to the OC stage, that will probably not work at all. But yeah, I'm going to have a try. Yeah. The other thing I'm interested in is pushing, getting hold of, I think the name is Manny, who did the ARM64 IPXE code that you use for booting your Ampere boxes. I have a couple of these lying around now, and the code you guys use is not the same code as upstream in IPXE, so the general public versions of that don't work. I think there's about 6 or 7 commits difference, so I'm hoping I can get hold of Manny and try and get that stuff upstream so everyone has the same love that we do. And also probably my main long-term interest is trying to get FreeBSD support into Tinkerbell and into Equinix faster, because we're releasing versions faster than you're deploying them, and I think that's a crime. Yeah. And finally, this is more maybe not related for Tinkerbell, but for FreeBSD, I'm trying to get an entire FreeBSD image wedged into the single EFI file that we download, which would make deploying FreeBSD stuff on Equinix hardware and my own stuff ridiculously easy, because IPXE would download one file and then you'd be done.
Nice. Okay.
Yeah,
I mean,
yeah.
I have a lot of personal questions around all of this as well. I don't know if you want to add that to the last topic of the meeting so we can have further discussion.
I'll stick them in at the end and we can talk later. Awesome.
Fantastic. Okay, that's fantastic. I'm very excited. Gianluca is first on the topics. However, he has not joined the call. I'm not sure where he is right now. I'll leave it for him to discuss, but he has a lot of fantastic plans for functionality, and he has enabled GitHub discussions on the repository. So what that effectively means is that we can have threaded discussion around various topics. If he does appear, then I'm sure you'll want to discuss that in more detail. But that's something that will be up and coming. I guess with that, next topic is myself. Oh, there. Which keep. Okay, fantastic. So I've got 2 things that I've added to the list. The first is docs. So I have been writing quite a lot of documentation around Tinkerbell, mainly originally focused on kind of the theory behind writing actions and writing workflows. And now I have finally gotten around to writing documentation around specific operating systems. I have added in documentation for review around Ubuntu, Debian, and FreeBSD as of today. That is on the Tinkerbell docs. Whoever is free and wants to have a read through that. The idea behind all of these is they discuss a number of different ways of deploying the same operating system, effectively to give people choice and the idea around how they would like to go around that. A lot of it is around either kind of using OS installers or when the vendor actually provides it, using the cloud images that they actually provide. Cool. And then the second topic that I was going to do, this is not going to be the most exciting thing, so I'll kick this off as quickly as possible, is as of, I have to share my entire screen. As of last week, I decided to test one of the newer actions around deploying Windows operating systems. So this is my very messy development environment for Tinkerbell. Move this out of the way. So we can see here I've got 3 templates that I've defined, a bunch of different OSs, and these are effectively using actions that are going to deploy over images. Let me just quickly clear a workflow. So what I'm going to quickly do is I'm just going to create a new workflow and quickly provision, but effectively this is a demonstration which shows how fast we can deploy a Windows image. I think this should work. So what I'm doing is using the right template. Okay, yeah, so I'm deploying a Windows 10 image using a image action, which I'll show you in a second. Okay, cool. So I'll leave this running in the background, then I'll actually tell you what's actually transpiring. There we go. So what I've done is I have linked that template to a new workflow and kicked off the server that is going to boot from that. So the server on the right is going to boot over iPXE. It will speak to the Tink server, and what we can see now is it's actually started to kick off. We can see a number of Docker containers have started and stopped, and these are effectively the actions that are taking place on here. So what is actually transpiring? So the template that I showed you on the window on the left. Here we go. This Windows 10 template. It's quite simple. If I cat win10 YAML. Okay, so this is the template that's actually going to run. It is 2 actions that are actually going to take place, and actions are Docker containers that are on the artifact hub that we can pass specific bits of information to them. We effectively have a Windows 10 raw image, so that is a block by a byte by byte copy of an underlying block storage that is compressed to save space. So that's why you can see the GZ extension. What effectively is happening is that the action is being ran on our remote host. It will stream that raw image through a decompressor and then write that directly to that underlying block device, so /dev/SDA. I'm adding in additional compression support. So for instance, FreeBSD, their raw images use the XZ algorithm. So I'll be adding that in there, and ideally we'll leave it as is, and we will effectively evaluate the extension of the URL to work out what compression type is used. Once this action is finished running, it will then effectively just do a reboot, which will boot us straight into that newly provisioned operating system. So this normally takes around 2 minutes or so. So I don't think we should be too much longer. But as mentioned, I've updated a lot of the documentation over the last few days. I've added in using this sort of method for OSs that actually provide it. So a lot of the Linux distributions all provide either QCOW or raw images. We've added documentation on how you would convert from a QCOW to a raw disk. And then we're adding an additional, there we go. So we can see now another Docker container has started and finished. This machine is going to reboot. 150 seconds, and that logo should look familiar. We're now booting into a provisioned Windows system. So yeah, we're adding a lot more documentation, how we would use Packer to do these sorts of things, how we would use different operating system types, bootstraps. VMware is quite a complicated one. They don't provide any way of creating these images or doing that sort of stuff either. So yeah, there's kind of a lot of things we're working on at the moment. Cool. So that's it. Does anybody have any questions around that sort of thing?
Yeah, that looks pretty neat. What sort of format do you accept there? Is it just effectively raw disk images that are just gzipped?
Yes. So the reason why it has to be a stream of data. It can't be anything where we need to do block searches. So QCOW, for instance, has table lookups for clusters of information. We needed to effectively, by using a raw image that starts at byte 0 all the way to the end of a disk image. It includes the bootloader, the partition table, the partitions, and the data there. So that makes it much easier. We can then take that raw image, compress it using either a format that supports streaming, and then just stream that straight to a block device.
That's awesome, because that's one of the features I asked for like about a year ago. We know what your hardware looks like. We just want to deploy an image on it. Can we just have a way of just saying, here's the URL, please put that on the disk, we'll take it from there. That's great. Yeah.
That's good to hear. Excellent. Does anybody have any other questions? All right. Jacob, it's down to you.
Oh, awesome. Thanks. I'm going to share my screen here real quick. So I've got a proposal out to reimagine Boots. If you're not familiar, real quick rundown of Boots, right? Boots does a lot of different things for us. DHCP server, it does our Pixie stuff, TFTP, HTTP. It does a whole bunch of custom installations. It's a syslog server. It's got hardware discovery endpoints, et cetera. There's quite a bit in there, right? So this proposal is to, just kind of a thought exercise with a small little demo to think about how we could reimagine the way Boots is and what it does. With some of the goals being to split out some of the functionality that's, Equinix metal specific, make it more generic, remove a lot of the extra things that might not necessarily be needed, or just makes Boots in and of itself kind of heavy and a little bit difficult in terms of a code base, right? And also to add DHCP proxy DHCP support, which would mean we could bring in your own DHCP server, which I think could be valuable in a lot of instances, especially just getting started. I think most people have their own. If you're going to run it from your own local box or local network, you just kind of plug and play. Because then you don't, for me at least, when I first got started, right, I have some maybe fancier network gear, so I had to create like a VLAN, a specific network that didn't have DHCP, so I didn't get conflicting. Anyways, I thought this would be helpful to have something like that. So there's a lot in this. I put a link in the doc. I kind of wanted to highlight this general idea. For me, I generalized, that's not going to come out well. I generalized Tinkerbell into kind of 3 phases. This was just for my mental map. There's a Pixie phase, there's, booting the operating system installation environment, and then the actual OS installation, right? While these might not be all of them, this was for this proposal, these are kind of what I drew up. And I wanted to focus here, right? How could we redefine or reimagine Boots just in the Pixie phase, right? Because if you think about it, Boots technically shouldn't be involved in anything here, or even anything once the installation comes on, right? Or very little involvement at least, right? And so the idea is to break out some of this, right? Boots could become just a DHCP server. It could be bring your own, right? And then you could ideally pull out some of this functionality and say just the Pixie serving of Pixie files is just its own thing. And then we could even have a rules engine to determine everyone's different use cases about what images, what kernels, what RAM disks should be served up, when and to who and to which clients. So I have a kind of demo. I'll run it through real quick if that's okay. But there's a repo here that kind of talks about that. So in this demo, some of this image here you'll see is implementation detail. I'm using a project called Pixie Core, but we could rewrite boots to do a lot of this in and of itself. But the general idea is that you could define, well, you're not going to see a big difference actually, right, from our current implementation, right? You're going to boot a machine and it's going to load up an operating system installation environment. The difference is under the hood, right, is that we are using, the demo shows I'm using an existing DHCP server, and we've broken out some of this into some cleaner lines like this, right? So I've got, in this repo, you'll see there's a Docker Compose file. So we've got our Tink, we still need Tink obviously, and we've got the database behind it, the CLI, etc. Here's where we're running Pixie Core, and this is Pixie Core's calls out to an API, and I've got a little service here that I call Dewey that just says, oh, hey, here's let me go talk to Tink. I'll grab from hardware data some operating system information like kernel and an NRD, and I'll serve those up through Pixie Core. So that's running here, right? This is, we've got a few different hardware profiles here that I'll show, right? So I'll show an Aussie boot real quick. I'll show a netboot XYZ, and then I'll show a boot up of Hook. So let's start with netboot. So we'll push that in. You can see right here, Tink responded, right? We push that in. So if we come over here and we start our virtual machine, or a bare metal machine, right? You'll see quickly over here that the Pixie Core server is talking. We've already got the netboot stuff. Technically, we've already served this stuff. This kind of idea of a phase, Pixie phase is technically done, right? Here we are already in XYZ, and we can boot up into that. So let's quickly change gears. Let's go to Hook. We'll push that one in. I guess it might be helpful too to look at some of these. The hardware data is pretty basic. We could trigger off of anything. I decided to use an existing field in here. You just tell it where you want to get these two files, and it'll go and get them. All right, so let's reboot real quick. So again, DHCP. So this is my home network. So it's going to actually get a DHCP address from my home network, right, like we talked about. And then proxy DHCP will inject and say, okay, here's where you're going to go get your files. So serve those up, booting into the kernel. There it goes. You should see the Linux kit stuff for Hook pop up here shortly. Almost there. There it is. Welcome to Linux Kit. And we're inside. We could go in, look around, and watch Tink Worker, etc., go on to play. So let's drop into the last one really fast. We'll do the regular Aussie one, or OC, depending on how you pronounce it, I guess. And we'll restart it up. And that'll kick off. Right, let's look at, you can see the logs going above. It's serving out OC, the init RAM-FS. Right, pretty straightforward. The only difference here, right? You've got your Mac, obviously, those kinds of things. It's just where you get these files. And like I said, we can do this today. already. It just is kind of a back-end implementation about how we can do a little more plug and play, allow for more integrations and kind of make the code base a little bit more maintainable and easy to reason about. For me, at least, the introduction into Boots, there was a lot of there's a lot in there, just kind of Equinix specific, and just kind of over the years, a lot of it build-up of different things that it did. And I found it a little bit difficult to reason about a lot of those things. Anyway, so this one, the Nix will boot up, and then we'll drop into OC there, and that's it. So yeah, this was the idea. I haven't put the proposal out for PR yet, but I thought I'd kind of bring it up here and see what people's thoughts or reactions and get a little feedback. So that's it. Appreciate it. Any thoughts or questions or comments?
That was amazing. Such awesome work.
That's my feedback too. That's epic.
Oh, thanks.
All right. That was really good. Thank you very much for that. I am very intrigued to see where that goes. As you mentioned, there is a proposal in the Tinkerbell proposals folder. So yeah, if you have thoughts, then please jump on that. Really good. Next on the list is Marky.
Gianluca just joined. If we want, we could toss it to him to go over the GitHub stuff, and then we could do mine or whichever. It doesn't matter.
Hey, feel free to go. I can skip and do the last one. Don't worry. Thank you.
Okay. So just wanted to let everybody know that this is the EMEA meeting. There is going to be an Americas meeting that will start tomorrow. One of the things that I wanted to just double check with everybody is I think the plan is we're going to stagger the meetings, so both meetings do not happen on the same week, because then it'll just sort of be duplicate content. So we will have the Americas meeting tomorrow, and then we will stagger. So they will not, EMEA and Americas will not happen on the same week. They'll happen on alternate weeks, but the schedules will be bi-weekly. So I just wanted to let everybody know we are working on getting a public calendar set, and these both meetings will be on that once we get that all worked out. But if anybody has any questions, comments, concerns, definitely drop a note in Slack, and someone will be able to address those. That was all I had, so I will turn it back over to you, Dan. Thank you. You are on mute.
Testing. Yeah, sorry about that. Yes, thank you very much for that. Thank you very much for taking care of the alternate set of meetings. I'm really hoping having that in a better time zone for everybody in the Americas will also make it a better experience for everybody out there as well. Gianluca, if you want to cover the GitHub discussion.
Hey, yeah, sorry, I got grabbed from another call, so I was late. I will watch the demos that I saw briefly at the end of it later. Yeah, we started to, we enabled this GitHub discussion for Tink. So not yet for the other repositories. We are mainly playing with it to see how it fits in the workflows. And something good about them is that you can have threads, so you can have nested conversations. So it's not like a flat like an issue, and you can upvote the discussion you want. We can categorize them almost like a forum. So yeah, we moved some of the issue that were discussion oriented, convert them to a proper discussion. So ideally, we can also see them as a gatekeeper, like when something is actionable can be an issue, seen as an issue, and when it's more like an open chitty chat, it can be a discussion, I suppose. But yeah, it's there, so have a look and let us know what you think about them. That's it.
Fantastic. And finally on the list, I'm not sure whether to call you Dave or DCH, but it's down to you. Have we lost him?
I'll see if after Dave, I'm literally just picking up my kid from kindergarten. So I'm here, I'm back again.
No problem.
Yeah, so if there was a question for me, you have to repeat it.
Oh, yes, sorry. Yes, I don't know if you're available to go through the topics that you added to the list.
Yeah, would be, I don't know if this works for other people, but if I got like 10 minutes, then I can get him home, offload him, and then I'm free to speak again. So I can ping people back on Slack if that works. Or
That's fine. Yeah, we can take these questions offline and have them in the Slack channel. Then we can add these back into the documentation for people to read at a later point. That's not a problem. Okay.
awesome.
Thank you.
Well, I'll ping you back on Slack in a few minutes then. Great.
Yeah,
Thanks.
that's fine. Fantastic. Thank you very much. Okay. Thank you very much, everybody, for joining. Before we go, is there anything that anybody wishes to add or bring to everybody's attention? 3, 2, 1. No. Okay. Well, thank you very much, everybody, for joining. There's new meetings coming. We've enabled kind of discussions for further conversation. There's new proposals being added. There's a lot more documentation starting to appear. There's a lot of kind of things happening at the moment. So thank you very much, everybody, for your work and your time. And we will speak to you all next time. Thank you, everybody. Bye.
Cheers, all.